Welcome in Dark Core. Mankind has been looking up at the stars for centuries, wondering what lies out there in deep space, and if there are other civilizations like ours that exist. We started using telescopes, but when that wasn't enough, advanced technology led to the creation of space probes so we could get a better look at our solar system and beyond. The Voyagers are two of the most iconic spacecraft mankind has ever invented and launched into space, and they are still out there hurtling through the cosmos. And after 7 months of silence, the amazing Voyager 2 once again called back home top Earth. Now get ready to find out more about these amazing spacecraft, the incredible things they found, where they are now, how far they have traveled away from us, and what is in their future. Logo. In the history of spaceflight, only 5 spacecraft launched by humanity had the momentum to leave our solar system. The Voyagers are 2 of these spacecraft, and they ended up discovering more than we thought they would, and have lasted a lot longer than NASA predicted. We think they are just not given the love they deserve, so we're going to tell you some really interesting things about them you might not know, what they have discovered, and where they are headed. Officially approved back in 1972, the Voyager project was originally called Mariner I Jupiter-Saturn, and the probes were previously named Mariner 11 and Mariner 12. But NASA decided to change the name because these 2 new probes had progressed sufficiently beyond that of the Mariner spacecraft family. In other words, they were much more advanced. Now, while we're on the subject, it's really interesting to look at the technology and hardware of these vintage probes. These spacecraft were launched an astounding 44 years ago. Voyager 2 on August 20th, 1977, and Voyager 1 2 weeks later on September 5th, 1977. This was at a time when important advances were made in the science of gravity-assisted orbital trajectories, or in other words, the ability for spacecraft to use the gravity of a nearby planet to give it a large boost in velocity as long as the spacecraft follows the intended or mapped-out orbit. First, let's talk about the computers, which are identical in both spacecraft. Each computer system aboard the Voyager spacecraft is dual redundant, meaning there was 2 of everything in the event one computer system should fail. The computers aboard the Voyager probes each have just 69.63 kilobytes of memory total. That's only enough space to store an average-sized JPEG photo file. Each of the space probe scientific data is encoded on old-fashioned digital 8-track tape machines. However, they aren't anything like your grandfather's 8-track stereo in his classic muscle car. There aren't any physical examples that exist, or anything sitting in a museum somewhere, but we do have a photo of it. Yes, this is the data tape recorder that was subcontracted to Lockheed and manufactured by Otis Corp for both Voyager spacecraft. It could record data at 2 different speeds, 115.2 kbps and 7.2 kbps kilobytes per second. Playback topped out at a much slower 57.6 kbps, with 33.6, 21.6, and 7.2 kbps being options as well. Exactly what the magnetic tape was made of, and what secrets we used to keep it from degrading in the harsh environment of space is unclear. Whatever those secrets are, they seem to have worked because the DTRs in both spacecraft performed flawlessly from their launch through the entire Grand Tour mission, and even the extended mission that set both of these spacecraft on a course out of our solar system. The Voyager spacecraft computers are capable of executing about 81,000 instructions per second. Your smartphone that you might be watching this video on is probably around 7,500 times faster than that. They transmit data back to Earth at 160 bits per second. To give you an idea of that speed, if you use this same connection, it would take you around 8.5 years to download a 5 GB movie from Netflix. But probably the most interesting thing aboard each spacecraft, the Voyagers have something no other spacecraft have, a golden phonograph record. These 2 gold-plated copper discs contain 115 analog encoded photographs, greetings in 55 languages, and a 12-minute montage of sounds on Earth and 90 minutes of music. These were made in the event an extraterrestrial civilization ever finds one of the probes. Powering each spacecraft are 3 plutonium dioxide radioisotope thermoelectric generators, or RTGs, mounted at the end of a boom. Each probe was fitted with 11 different scientific instruments, which if we explained in detail would take easily over an hour. Narrator, do not narrate. Video editor, put on screen as text. 1. Imaging Science System, ISS. 2. Ultraviolet spectrometer, UVS. 3. Infrared interferometer spectrometer, IRIS. 4. Planetary Radio Astronomy Experiment, PRA-5. Photopolarimeter, PPS-6. Triaxial Fluxgate Magnetometer, MAG-7. Plasma Spectrometer, PLS-8. Low-Energy Charged Particles Experiment, LECP-9. Plasma Waves Experiment, PWS-10. Cosmic Ray Telescope, CRS-11. Radio Science System, RSS. Instead, let's look at a few of the exciting things the Voyager probes found and the images captured during their missions using these instruments. Both spacecraft have been traveling along different trajectories and at different speeds. Voyager 1 is traveling faster, at a speed of about 61,155.07 kilometers per hour, 38,000 miles per hour, compared to Voyager 2's velocity of 56,327.04 kilometers per hour, 35,000 miles per hour. Narrator, give a 2-second pause between the planets so we have some time to show some images. Voyager 1 captured incredible images of Venus, Jupiter, Neptune, Saturn, and Uranus. Voyager 1 also captured an incredible image of Jupiter's moon Io where a volcano was seen erupting from the surface. It was the first time ever that an active volcano had been seen elsewhere in the solar system. But the most famous image Voyager 1 captured was of the Earth, or what is famously known as the pale blue dot taken February 14, 1990 at a distance of 6 billion kilometers, 3.7 billion miles away, and inspired the title of Carl Sagan's book, A Pale Blue Dot, A Vision of the Human Future in Space. Voyager 2, on the other hand, began transmitting images of Jupiter on April 24, 1979 that were put together to show a time-lapse movie of the gas giant's atmospheric circulation, including the infamous Great Red Spot Storm that is 3 times the diameter of Earth. Voyager 2 was able to do this because it made closer passes to Jupiter and the Jovian moons. On August 25, 1989, Voyager 2 flew by Triton, one of Neptune's moons. The Voyager 2 data was used to construct this video of its exciting encounter and showed us Jupiter as we had never seen before. Between them, Voyager 1 and 2 explored all the giant planets of our outer solar system and 48 moons, a unique system of rings, and the magnetic fields of each of the outer planets. But this wouldn't be all Voyager 1 and 2 would discover, as you're about to find out. In fact, they would encounter something far more mysterious and unknown, and something they weren't even designed for. Voyager 1 entered interstellar space on August 25, 2012, and was the first human-made object to do so, as Voyager 1 left the heliosphere, which is a giant bubble of charged particles that the sun blows around itself. The probe recorded a 1,000-fold drop in heliosphere particles and a 9% increase in galactic cosmic rays that come from outside the solar system. Since flying into interstellar space, Voyager 1 has sent back some information about the conditions in this dark zone of the universe. One of those discoveries is that the cosmic radiation out there is very intense and demonstrate how charged particles from the sun interact with particles emitted by other stars, and how this bubble of charged particles protects everything inside our solar system from those deadly cosmic rays. On November 5, 2018, Voyager 2 became the second spacecraft ever to enter interstellar space when the probe registered a sudden decrease in solar wind particles emanating from the sun, and at the same time, it also experienced an increase in galactic cosmic rays and the strength of the interstellar magnetic field. Voyager 1 has continued to astound engineers when in December 2017, it successfully used its backup thrusters to orient itself so that we could communicate with it back here on Earth. Those thrusters hadn't been used since November 1980 during Voyager 1 flyby of Saturn. How's that for reliability? The Voyager probes are always sending out a signal. Each probe has a 22.4-watt radio transmitter, which is about equivalent to a tiny refrigerator light bulb. The mind-blowing thing is that by the time its signal reaches us, the power has been reduced to roughly 0.1 billionth of a watt. It's so small that NASA has to use its Deep Space Network array of giant radio antennas together, which consists of 3 facilities spaced apart from each other around the world. The Madrid Deep Space Communications Complex, the Canberra Deep Space Communication Complex in Australia, and the massive 70-meter, 230-foot antenna at the Goldstone Deep Space Communications Complex in Barstow, California. The sensitivity of NASA's deep space tracking antennas located around the world is truly incredible. These huge antennas must capture Voyager information from a signal so weak that the power striking the antenna is only 10 exponent minus 16 watts, 1 part in 10 quadrillion. A modern electronic digital watch operates at a power level 20 billion times greater than this incredibly feeble level. And we're not done talking to the Voyagers just yet. On October 29, 2020, mission operators sent a series of commands to Voyager 2 after a long 7-month silence. The spacecraft had been flying solo while the 70-meter antenna at the Goldstone Deep Space Communications Complex was being repaired and upgraded. The amazing thing is that after all these years and the fact that Voyager 2 is in interstellar space, it returned a signal confirming it had received the call and executed its new commands without any issues. As of January 2022, Voyager 1 is 23.3 billion kilometers from Earth, 14.5 billion miles, and Voyager 2 is 19.3 billion kilometers, 12 billion miles, from us. Most of the instruments have been shut down on both of these probes in order to conserve power. Voyager 1 is headed in toward the constellation Ophiuchus, and in the year 40,272 AD, it will come within 1.7 light-years of an obscure star in the constellation Ursa Minor called AC plus 793888. In about 40,000 years, Voyager 2 will come within about 1.7 light-years of a star called Ross 248, which lies in the constellation of Andromeda. But sadly, and much sooner than this, we'll lose contact with both of these spacecraft for good, and they'll pass silently into the interstellar void. It would be interesting if one day, in the very far and distant future, a civilization somewhere out there finds a Voyager and learns to power it back up. If so, that primitive hardware might spin back to life one last time. Stay tuned here to see if the Voyagers find something new, and to keep up with all the exciting things happening in our universe. Thanks for watching.